Hello, everybody. Today we're going to talk something about uh, the latest processor technology on cell phones and other things. Okay, what are the different things that you have in a cell phone? Okay, what are the things usually you look into? First thing is clock speed. Okay, clock speed is something which the rate at which it is going to run the processors and things like that. Okay, and some of the so there are different things. One is processor cycle, how fast it can do, and switching elements for memory, which is how fast it is going to do, and IO acceleration, which is how fast it's going to do the IO or things like that. Okay, so these are the basic things: IO bottlenecks, processor bottlenecks, clock speed bottlenecks. These are the things that you are going to look into any kind of capabilities of a particular machine. Okay, so today we are going to see something to do with uh, G99. Okay, that is a processor, MediaTek Helio G99 features. Okay, it is an octa-core CPU with two high-performance ARM Cortex. Okay, A76 processor clocking up to 2.3 gigahertz, 2.2 gigahertz, and a highly capable ARM Mali G57 class GPU. Okay, so basically it has got a CPU and GPU. Okay, so since it is octa core, it means that it has got 8 processors. Okay, so basically your system has 8 processors, and there are two processors called CPU and GPU. Okay, CPU is the central processing unit, and GPU is the supportive processor unit, mostly used for input output technology and other things. Okay, so there are when you just have a thread and you're going to give away the thread to somebody else, then it is going to use the GPU. Okay, and it has got its own private memory. Okay, what are the LPDD R4X? Okay, memory up to 2.1 megahertz. Okay, 2000 megahertz, and fast UFS for the 2.2 class storage accelerate data access. So it is going to have a super fast data access because it's running almost like 2000 megahertz. Okay, so that is a clock speed which you can access the memory location. Okay, so it has got how many memory locations it will have? It will have, since it has got 8 processors. The first two CPU will access about something. Okay, so about say you have 6. Okay, 6 GB is the thing. Okay, so it is going to take 2 for the main process, and 4 is going to be left out for the other process. Out of this 4, each processor 6 processor will have 6 memory locations. Okay, so 6 memory locations plus another 2 GB memory location, which so totally about 6 GB or 8 GB internal RAM. So the 6 GB, 8 GB internal memory location is called is mainly used as a kind of capacitor kind of memory location. So the GPU usually has its own private kind of not private, it is just half private and half public kind of thing, and each two processors of GPU will have access to the same location. Okay, kind of thing, so that it maps up. Okay, that is a kind of thing. So about 6 means you have 3 shared memories, which is going to access this, and one root memory which is going to access by the other two CPU process. Okay, so this is how the shared memory looks like. Okay, that is the kind of architecture that is going to have. Usually when you run a Unix operating system, first thing you have to map all these things before you run a process. Okay, process, or where you're going to have the file system and things like that. So when you allocate something like for performance and other things, what you are going to do is what is called a swap. Okay, So you're going to create what is called a swap area in case of Unix operative systems. Okay, this swap area is where the actual your shared memory will be allocated. Okay, all this memory, okay, RAM memory, they are using the going to use the swap. Swap is the only place where you can put on things from the slow devices onto that particular swap device, and the processor is going to run from that, and anything that is currently running on the processor will be taken from the swap device only. It won't be taken from the memory location, other hard drives or anything like that. Okay, so in order, if it has any kind of problem, it is going to create an interrupt saying that I'm running out of space or something like that, and then it is going to fetch for the switch over the process and fetch for the next uh, load of instruction set, or kind of stack set, or the other kind of instruction set or data set or something like that. Okay, so in order to do all the switching of these things, they'll have what is called a mirror kind of thing. Okay, mirror kind of thing where all the GPUs and CPUs will mirror its own kind of shared memory and allocate it in proper way so that it has all the things and it starts. So first thing, you have to create a mirror of whatever file systems you have and things like that. Some of the things you use file system as such is loaded onto some of the mirrors. Sometimes the file system itself is not loaded onto the things, part of the file system of useful file tags and things like that. Usually the bin and other things are all some of the binaries and other things which are currently running. When you give a process, when you start a process, immediately that particular thing is get loaded into the swap area. The swap area is where the actual RAM sits. Okay, some of them, the boot area is where you have the actual code running, and sometimes it might be read only kind of thing. Okay, the boot area. So then you create the swap area, then you create the other locations for user access and other things. Swap area is the only thing where it is going to put all the things, all exes and other things, keep track of all the tabling and other information as for how to run a process and things like that will be thing. And these swap areas are the one which we are talking about, and it has got, so in this case G99 will have uh, about space about six total space will be around 6 GB. So 2 GB will be used for the by main CPUs, and 3 GBs will be used by the other other kind of process like the GPU and other things. Okay, so this is how the architecture is. So it is run by ARM. Okay, ARM is so risk management. Okay, advanced risk. Okay, advanced risk architecture. Okay, so that is why it is called ARM, and it is an octa core, which means that it has got 8 processors. Okay, so when you are looking into multiprocessing architecture, they usually call it CPU GPU. Okay, not all CPUs are used as kind of accessing the shared memory, or kind of entire memory and things like that. So some are given away by GPUs, because when you want to align some of the things and you want to schedule some of the things, then if it is going to wait on something, then mostly it is something to do with GPU. Okay, so it will be switched on to GPU and things like that. So if it is going to wait on an IO, or it is going to wait on some other kind of bus access and other things, it will all be done. Slow devices and other things will be connected only to the mostly to the GPU, and CPU will usually access the main memory kind of thing and then start using the thing. So the swap area itself has got 2 sections. One is the main memory, another one swap memory, where you have the main processor accessing part of it, and part of it is accessed by the GPUs and other things. Okay, so how frames per power savings combine hardware and software enhancement, reduce power consumption and other things. Okay, so the networking engine, dual 4G voltage and things like that. Okay, those are all how you find out. 6 ARM cortex of this thing. Okay, cores is octa core, which means that So the camera and all is kind of extension device which is going to be accessed really fast and things like that. So CPU bit is number of CPU bit is 64-bit architecture. So the first thing you have to know 64-bit. 64-bit means it can go up to 64 gigs, I think. And suppose it is going to 64 makes up 64 gigs, you can have shared memory architecture. Okay. Heterogeneous multiprocessor. Okay, it is not a homogeneous. Homogeneous means all processors are not running at the same speed. So it is heterogeneous, which means some of the processors are going at higher speed, or some are also used for some kind of reserved area or something like that, and some process will be run on those things, and that is why the CPU has and GPU is the next kind of. So that is why it is here heterogeneous multiprocessor. Memory storage, okay, memory type, okay, and other things, okay. So it has got what are the AFS and single cam, dual cam, then you have warping, shutter compensation, and other things. So memory is LP, DDR, okay. So 4x. So these are all accelerators for the particular accelerator. So the memory type is usually accelerate the kind of display and other things. That is why display, your keyboard, your touch screen, those kind of things are accelerated. That is why you have two types of memory type. Okay. So LPDDR 4x means it has got four partitions within the memory locations, and each one of the partitions used for accelerating some of the things. Maximum memory frequency storage UFS is 2.2. Maximum display resolution memory type is the thing. Okay, so these are the kinds of things which you want to see. Okay. Video encoding, decoding, those are not. So some of these accelerators, what they actually do, so why do you want a GPU and other? They do some kind of encoding and decoding. Those kind of processing should be done on GPU. Okay. So if you want to do any kind of fast Fourier transform, if you want to do any kind of conversion of some of the encryption technology, and if you want to do any kind of conversion of high definition to low definition, those kind of things, and or zoom methods, so increasing the voltage kind of thing and faster processing, if you want to switch on modes to different process speed and things like that, those things are all done by GPUs. Okay, that is have separate memory for those things. So those separate memories do all the different types of things for kind of compression technology, FFT technology, then other things are done by those kind of GPUs, which it's a kind of reallocation of some of those. Even encryption technology is done by the GPU rather than CPU. So these are the basic things you have to understand how a processor works, what are the different parts. So if you want some kind of cell phone, then it is an octa-core, and number of bits is 64 bits and things like that. So the latest things are all 64-bit kind of architecture. Okay, we still haven't touched 128-bit, but 64-bit is quite good enough for any kind of cell phone and other things, for normal processing and other things. Okay, because you don't have a very wide screen or something like that where you have to do extreme fast processing or something like more. Even if you need those kind of processing, you can do it on a server. The server takes care of all the things. Some of the servers, they have their own CPUs, GPUs, like a Unix operating system, and some of the cloud servers, they have all the things. So you don't have to worry about your feature and other things. But basic things of how your system will work, the compression ratio and other things, how it is going to calculate, those kind of things are all done here. So while you're taking a photograph or something like that, it is going to compress those photographs. This compression thing is going to be done by what is called the GPUs. So 2x ARM Cortex A76 up to 2.2 gigahertz. So and 6 ARM Cortex A55, okay, up to 2 gigahertz and 2.2. Okay, so this is the clock speed for each one. So two will run on 2.2 gigahertz, and because it can multiplex the instruction set, you have two processes. Okay, two processors can easily multiply, access the same kind of location and things like do some kind of multiple. That is why they have those guys. So internal transfer is really fast. Say if you want to, do a compression algorithm for a particular thing, so then because the two core processor nearby, you can easily share the memory and do it really fast. Those kind of things. So 6 ARM Cortex A55 up to 2 gigahertz. So 6 ARM Cortex. Okay, so the ARM Cortex is the one which is going to be surrounded kind of. So it's an A55 kind of processor. Okay. Now these terms A55 gigahertz, usually people know what speed it's going to run. ARM Cortex, ARM means it's something to do with a RISC kind of architecture. A76 means it's got different connotations for each one of those depending on what kind of processors they release. Okay, each one has got different styles of management and things like that. So this is just a general overview of what is a CPU, GPU, how shared memory works and things like that. Okay, next we go into the Unix operating system where you are going to use the different kind of memory types and other things. Okay, so in order to see some of so the whole thing of memory of internal memory or RAM is the one which is going to run here. So where your programs and other things are going to be swapped in, swapped out and things like that. Okay. So when you say swap, it means that it is going to write into the swap device and it is going to write into your main memory or shared main memory and things like that. And after that, it is going to get out of the once the program is executed, it's going to get out of this. Or if it is waiting, then it is going to switch over to it is going to write part of the thing into the disk, other kinds of disk, flash disk and other things, and then switch over the process to the next thing. As long as it's going to wait on some kind of IO or bottleneck or processing bottleneck, or it is doing some kind of process, so it will deallocate the things to GPU and then wait. Okay, that is a kind of thing. Okay, since it takes the next instruction and other things. So this is how the things work. When you say 108 megapixel main camera, so this camera has to be run by what? This camera, when it wants to capture all the things of the very good things and other things, so it is running at 2.133 megahertz, and it is going to do all the fast processing, fast Fourier transfer on the screen, and a number of bits and other things. It's going because it is going to have a huge memory. Okay, so 108 megabits. Okay, megabits per second. So it is going to receive so much of pixels. Okay, and it has to process those pixels. That is why we have a GPU. Okay, usually each one of those GPUs is allocated to some kind of device where the device takes too much of I/O to do some kind of. So when you do a touch on the screen requires quite a lot, and similarly, the cameras need quite a lot to do some kind of processing and things like that. And sometimes even the games using cameras and other things are going to be quite difficult. So you just have to have a basic understanding of how the camera works, why we won't need it when you have so much of memory requirement for a particular camera to record some of the things. Then that is why we have a GPU, why not CPU, everything is a CPU, and how to correlate each one of those things, why we want to have a different kinds of clocking structures just to make sure that some other things are slower, some other things are faster and things like that. So it's just a step ahead. Even for Unix operating system, you have to look into those kind of Unix or a BSD code, those kind of things are done. So basically in a BSD system we have what is called a slash. Slash is the main kind of boot area. So first thing you have to create what is called partitions. Partitions means different types of memory locations. Okay, and the disk drive. Okay, so the slash is the boot partition. Okay, slash is the boot partition usually created, so it will have basically the entire operating system out there. Okay, and then you have what is called a swap area. Okay, which is going to do all the RAM kind of thing, where it is going to put so the first operating system will first load itself from the slash area onto the RAM area. Okay, so RAM area, which is called the swap. Okay, and it is going to execute all the things from there as much as depends on what how much of memory it is going to do, and what are the different kinds of correct instruction it's going to do. The operating system has to run always, so it is going to have a minimal kind of thing downloaded onto the swap area. And after that it is going to have other kinds of disks, okay, where a user disk and other things slash user slash var, okay. So these are the four different types. One is called the slash, another was where it is boot things are going to be there and system requirements are going to be there. Then you go to swap area where you're going to take some of the things from the other locations and put it inside for processing. That is why it is called a swap area. And then finally you have two other disks which can be partitioned into other things, okay. So main partitions are slash var variable, and another one is slash user. So the user system, complete user system, is going to be on the last partition usually, okay. And before that you have what is called a temporary. What is the temporary kind of thing? Slash slash var variable kind of things. Usually when the processor is running in the swap area, so it is going to use some of the information from the uh, uh, VAR, okay. So temporary files and other things for those. So it's temporary location for the files where it is going to do while processing it. You want to switch over to some of the process and other things. That is why you have a slash var, okay, where temporary things are going to be put in, and it's a variable kind of thing where data can be huge and other things. So if you're making a copy instruction, okay, so you, from one disk to another disk or something like that, okay, from one directory to another directory, first it's going to load all the things of the information where from source location, destination location. First it's going to go give it to the, so it is going to keep some of the information in the slash VAR directory, and it is going to keep it as a temporary kind of temporary .temp file, okay. And that .temp file is going to go into it is going to take from the .temp file, and then it is going to load it onto the swap area. And swap area, once it loads onto the swap area, it starts executing the code. So BSC system works somewhat similar to that, okay. So the main locations of 1 2 3 4, okay. First is the boot area, second one is where it is slash is loaded. That is the first directory structure is loaded, where you usually have all the system kind of features only, okay. They are not going to user bin, other things are not going to be there. So you have a system bin, okay, whatever system commands and other things are going to be there, going to be stored there. Number two, its operating system itself is going to be stored there, running the current kind of processor and switching over the processor. Those kind of features are all there within the operating system. Those things are going to be system operation, like the screen buffering and all these things. It's going to be put in there, that area. And finally the register locations, for those kind of things, information is all going to be in the slash area. Then you have the swap area where it is going to use the memory as a kind of RAM, and from where the processor will take and switch over. Even the slash area, first thing, the boot thing is loaded onto the swap area. Only in swap area has the processor access. Other things he doesn't have any kind of access. So swap area is very important in case of RAM architecture. So you can divide the RAM also into different kinds of things, so that you can do relative addressing, and sometimes you can do what is called mirror mapping and things like that. So those are a little bit complex in different kinds of areas. So var is the next one, where you have variable data information, like if you have a huge data structures and things like that. So if things is going to do for quite a long time, there's a project which is going to be run overnight and things like that. So those kind of information which will take a long time and things like that, those kind of information, it has to be stored somewhere. So they stored it in the temporary. So temporary slash var is the one where temporary files are, so it will just switch over the things, and those are used only by the swap area. So usually the var is used only by the swap area and the process which is running on the system. And finally you have the user, where actually your data directory structures and other things are going to be there, and where you can store store it in a hard disk or something like that. So you can even partition the different types of hard disk and use them as a kind of. So there are two hard disks. One is for slash, another one is for slash slash user and slash var. Okay, so slash variable. So these are the mostly something to do with permanent storage kind of device or flash EEPROM and things like that. So mostly boot areas in flash EEPROM and things like that. So slash most probably might be in flash and boot area and things like that. So how to do different kinds of mapping and other things, how the BSD does different kind of swap area, how it uses, how it swaps the processor and things like that. So this is just an introduction because here have 8 cores. Then how would you, when you run in Unix operating system on something like this, you are going to use the first two processors, and you are going to use the first two processors area as some kind of swap area, and the GPU memory locations are going to be used as a kind of slash var or something like that. And finally you have the slash user area where you have all the other kinds of applications plus data storage and kind of other kinds of things are going to be stored, and other kinds of database and other things are going to be. Sometimes databases are required by some of the things, so it can take the database from the user area and load it onto kind of slash variable area and use those databases to access your things. So when you're basically accessing some kind of usually database files are extremely huge, so it has first load those databases into slash .temp kind of thing in the slash variable structures, and then it has to go access all those things. Say if you are going to run something, find a person in the whole world with a name like this, address like this, and so it is going to go access the whole entire world database. So when it's going to address the whole entire world database to search for a particular person on a particular location or with certain set of features, it is going to access a huge amount of data. So where do the data gets template? It is going to be in the var or temp section as a .temp file and things like that, and it have access to the different, so fetching things from different clouds and other things, and then finally processing those things, and finally putting on the display. So this is the kind of thing that is you have to look into when you are doing a architecture of how a multiprocessing system or kind of your how your system works and what kind of features it has got, because depending on the feature only you need GPUs and other things. Because you have a camera of 108 megapixel camera, it needs so much of memory, so that is why you have to do all the processing also for that, like conversion and other thing. That is why you have GPUs. Otherwise you won't have any kind of GPU and other things. Similarly for touch screen and other things, and the response also is there. Okay, so once you touch, immediately the screen scrolls and it moves the bits around and things like that. So amount of bits that has to be stored on the screen is also another big thing. Okay, screen, camera, then IO devices like sensors, and if you are having an internet about so it has about access about 8 1 GB 1 GB per second. Okay, so you have to create memory for 1 GB per second. Okay, so where you're going to store all this information, process the thing so it is going to be done by GPUs and other things. So the number of how much of IO and how much of IO can capture, those, it all depends on those things. That is why we have GPUs. Okay, CPUs are mostly for processing all the switching between processors and do some kind of home management kind of thing. Okay, so this is a general architecture, how to write a BSC system and other things, where it is going to happen, what happens where, those kind of things, information is given here. Okay, and just general look at what are the different kinds of architectures is available, why you have CPU, GPU, why, how they do different clocks, why we need GPU, why we need CPU and things like that. Okay, that is all for today about BSD and Unix features and other kinds of operating system consideration for multiprocessing systems. Okay, that is enough for today.